Good morning. Today I'm going to tell you about standalone and grid connected solar power systems. So, the contents for standalone power systems are introduction, types, hybrid systems, and the contents for grid connected power system are introduction, operation, advantages, and disadvantages. So, first, we will discuss about standalone power system. A standalone power system, also known as remote area power supply, is an off-the-grid electricity system for locations that are not fitted with an electricity distribution system. Typical standalone power system include one or more methods of electricity generation, energy storage, and regulation. So this diagram tells about the hybrid power systems. Electricity is typically generated by one or more of the following methods: photovoltaic system using solar panels, wind turbine, geothermal source, micro combined heat and power, micro hydro, diesel or biofuel generator, thermoelectric generator. Storage is typically implemented as a battery bank, but other solutions exist including fuel cells. Power drawn directly from the battery will be direct current extra low voltage, and this is used especially for lighting as well as DC appliances. An inverter is used to generate AC low voltage, which more typical appliances can be used with. A typical standalone power system at a sewage treatment plant in a Century de Lucian, Spain. Standalone photovoltaic power systems are independent of the utility grid and may use solar panels only or may be used in conjunction with the diesel generator, a wind turbine, or batteries. Types: the two types of standalone power systems are directly coupled system without batteries and standalone systems with batteries. Direct coupled system. The basic models of a direct coupled system consist of a solar panel connected directly to a DC load. As there are no battery banks in this setup, energy is not stored and hence it is capable of powering common appliances like fans, etc. Only during the day, MPPTs are generally used to efficiently utilize the sun energy, especially for electrical load like positive displacement water pumps. Impedance matching is also considered as a design criteria in direct coupled system. So this diagram shows about the standalone systems with batteries. In standalone photovoltaic power systems, the electrical energy produced by the photovoltaic panels cannot always be used directly, as the demand from the load does not always equal the solar panel capacity. Battery banks are generally used. The primary function of storage battery in a standalone PV systems are energy stored capacity and autonomy, to store energy when there is an excess available and to provide it when required, voltage and current stabilization, to provide stable current and voltage by interdicting transients, supply surge currents, to provide surge currents to loads like motors when required. Hybrid system. The hybrid power plant is a complete electrical power supply system that can be easily configured to meet a broad range of remote power needs. There are three basic elements to the system: the power source, the battery, and the power management center. Sources for hybrid power include wind turbines, diesel engine generators, thermoelectric generators, and solar PV systems. The battery allows autonomous operation by compensating for the difference between power production and use. The power management center regulates power production from each of the sources, controls power use by classifying loads, and protects the battery from service extremes. Now, the grid connected photovoltaic power system. A grid connected photovoltaic system or grid connected PV system is an electricity generating solar PV power system that is connected to the utility grid. A grid connected PV system consists of solar panels, one or several inverters, a power conditioning unit, and grid connection equipment. They range from small resident commercial rooftop system to large utility scale systems. A grid connected system rarely includes an integrated battery solution as they are still very expensive. When conditions are right, the grid connected PV system supplies the excess power beyond consumption by the connected load to the utility grid. A grid connected residential solar rooftop system near Boston, USA. Operations: residential grid connected rooftop system which have a capacity more than 10 kilowatts can meet the load of most consumers. They can feed excess power to the grid where it is consumed by other users. The feedback is done through a meter to monitor power transferred. Photovoltaic voltage by may be less than average consumption, in which case the consumer will continue to purchase grid energy but a lesser amount than previously. If photovoltaic voltage substantially exceeds average consumption, the energy produced by the panels will be much in excess of the demand. In this case, the excess power can yield revenue by selling it to the grid. Depending on their agreement with their local grid energy company, the consumer only needs to pay the cost of electricity consumed less the value of electricity generated. This will be a negative number if more electricity is generated than consumed. Additionally, in some cases, cash incentives are paid from the grid operators to the consumer. Connection of the photovoltaic power system can be done only through an interconnection agreement between the consumer and the utility company. The agreement details the various safety standards to be followed during the connection. So this diagram shows that the photovoltaic power station at Nellis Air Force Base in United States. Advantages: systems such as net metering and feed-in tariff, which are offered by some system operators, can offset a customer electricity usage costs. In some locations, though, grid technologies cannot cope with distributed generators feeding into the grid, so the export of surplus electricity is not possible, and that surplus is earthed. Grid connected PV systems are comparatively easier to install as they do not require a battery system. Grid interconnection of photovoltaic power generation system has the advantage of effective utilization of generator power because there are no storage losses involved. A photovoltaic power system is carbon negative over its lifespan, as any energy produced over and above that to build the panel initially offsets the need for burning fossil fuels. Even though the sun doesn't always shine, and any insulation gives a reasonably predictable average reduction in carbon consumption. Disadvantages: grid connected PV can cause issues with voltage regulation. The traditional grid operates under the assumption of one-way or radial flow, but electricity injected into the grid increases voltage and can drive levels outside the acceptable bandwidth of plus minus 5%. Grid connected PV can compromise power quality. PV's intermittent nature means rapid changes in voltage. This is not only wears out voltage regulation due to frequent adjusting, result but also can result in voltage flicker. Connecting to the grid poses many protection related challenges. In addition to islanding, as mentioned above, too high levels of grid connected PV results in problems like relay desensitization, nuisance, tripping, interference with automatic reclosers, and ferro resonance. Thank you.